Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at equivalent fractions. So two fractions, I'm going to call one of them A over B and one C over D. They are equivalent if AD equals BC. If this times this equals that times that. So that sounds a bit confusing, but basically what it's saying is two fractions are equivalent if you multiply or divide the numerators by the same thing that you multiply or divide the denominators. So these two fractions here, you can probably tell they are equivalent. A half and 5/10 are the same thing. Getting half a pizza is the same as getting 5/10 of a pizza. You know, if your team has won 5 out of 10 games, they have won exactly half of their games. So these two fractions are equal, so we put an equal sign. So this sign here means has the same value. These two fractions here have the same value. They're both equal to 0.5. So the reason they're equivalent is to go between the numerators, I multiply by 5. I multiply by 5 to get from 1 to 5. But to go from 2 to 10, I also multiply by 5. The same thing has been done to the numerators, timesing by 5, as the denominators, timesing by 5. So these two fractions are equal and have the same value. It also means they'll be found at the same position on the number line. So this is the number line between 0 and 1. All of these are fractions. So I've actually divided this into tenths. So you can see 5/10 lies here, but 5/10 is exactly halfway between 0 and 1. It turns out a half is exactly halfway between 0 and 1, would also lie there. Half lies there. 5/10 and a half are the same position on the number line. That means their equivalent fractions mean exactly the same thing. But what about a third and 7 over 24? Would they be equivalent? Well, what's been done to the numerators, the top numbers, is you've times by 7. You have to times 1 by 7 to get 7. But you actually don't times 3 by 7 to get 24, you times it by 8. So the numerator's been multiplied by 7, the denominator by 8. The same thing has not been done to the numerator and denominator. So these two fractions are not equivalent. That's what this symbol means. They do not have the same value, they're not equal, and they would lie at different points on the number line. In fact, a third would lie just to the right of 3 over 10, because it's a little more than 3 over 10, but 7 over 24 would be about here. It would be just to the left of 3/10 because it's a little less than a third. So that's what it means if fractions are not equivalent. So we can use equivalent fractions to simplify a fraction. When we simplify a fraction, we just find an equivalent fraction with the smallest possible numerator and denominator. So the way that you simplify a fraction is you divide top and bottom, numerator and denominator, by their highest common factor. So thinking about these fractions up here, 1/2 is simpler than 5/10. They are both equal, but this fraction has a lower numerator and lower denominator. So a half is the simplified version of 5/10. So we want to do something here. 16 over 40, little complicated this fraction. We're going to simplify it. So what we're going to do is we're going to divide the top and bottom by their highest common factor. So the highest common factor of 16 and 40 is 8. 8 is the highest number that goes into 60 as well as 40. So when you're simplifying fractions, what you do to the top, you must do to the bottom. If you don't do the same thing to the top and bottom, you won't have found an equivalent fraction. So 16 divide 8 is 2, 40 divide 8 is 5. 16 over 40 and 2 over 5 are equivalent. They're both equal to 0.4, but this is simpler because it has lower numbers in numerator and denominator. We simplify fractions because this is a lot easier to understand than this. If you were asked to, give someone 2/5 of your chocolate, that's a lot easier to figure out than giving them 16/40 of your chocolate. So let's try and simplify this fraction 48 over 144. So we want to divide top and bottom by their highest common factor. The problem here is it's hard to know what the highest common factor of these two numbers is off the top of our head. So if we don't know the highest common factor, we can pick any common factor and keep simplifying. So 48 and 144 are both even, so I know they have a common factor of 2. So I'll divide top and bottom by 2. So 48 divided 2 is 24, and 144 divided 2 is 72. But this is not simplified yet because these two numbers still have a common factor. So what I'm going to do now is find another common factor. So 24 and 72 have a common factor of 8. So I'm going to divide top and bottom by 8. 24 divide 8 is 3. 72 divide 8 is 9. But this number here is still not simplified because 3 and 9 have a common factor of 3. So I'm going to divide top by 3 and bottom by 3. 3 over 9 is a third. It turns out all four of these fractions, 1, 2, 3, 4, they're all equivalent, but a third is simpler than the other three because it has smaller numerator and denominator. 48 over 144 and a third are the same thing. It turns out the highest common factor of 48 and 144 is 36. But if you can't find the highest common factor off the top of your head, just keep simplifying by dividing by any common factor other than 1, and eventually you'll get your answer. Now, not all fractions can be simplified. 2 over 5 can't be simplified, nor can a third. 2 and 5 don't have any common factors, nor do 1 and 3. So not every fraction can be simplified. All right, let's now look at writing one quantity as a fraction of another. So let's look at this question here, where we have to write one quantity as a fraction of another. We just write the out of as a fraction and simplify. And we need to make sure units are the same. So let's look at this. Zach, an athlete competing a triathlon. The total distance of the triathlon, 4 kilometers, and he must run 1,500 meters. What fraction of the triathlon is running? So we're really asking, is 1,500 meters like half of 4 kilometers? Is it 5/9 of 4 kilometers? We don't know. That's what we're going to figure out. So we write the running part out of the total. Now this is in meters, so I need to make this into meters. So 4 kilometers is 4,000 meters. So 1,500 over 4,000 of the triathlon is running. I just need to simplify this now. So I can divide top and bottom by 100. That's the same as crossing out those 2 zeros. I have 15 over 40. So 15 and 40, their highest common factor is 5. So 15 divided by 5 is 3. 40 divided by 5 is 8. So that means that 3/8 of the triathlon is running. 1,500 meters is 3/8 of 4 kilometers. And when you think about it, that makes sense. 1,500 meters is a little less than half of 4 kilometers. 3/8 is a little less than half. All right, let's now look at comparing fractions. So we can use equivalent fractions to compare fractions. So in maths, when we say compare, we don't mean the same as in English. You don't say why they're similar to each other. Comparing fractions means we determine which fraction is larger. See, the thing is, it's really easy to compare fractions when they have the same denominator. So you can see very clearly that 3/5 is greater than 2/5. That's really easy to compare. Having 3 of something is always more than having 2 of something. But when the fractions have a different denominator, it's hard to compare. It's hard to tell which fraction is larger. So what we're going to do is use the lowest common denominator, which is where you find the lowest common multiple of the two denominators. So this gets a bit tricky. We used highest common factor when simplifying. We use lowest common denominator when comparing. So let's look at a kind of question where we're going to compare fractions. A school survey, 5/8 of students said they like soccer, 3/5 say they like rugby league. Which sport is more popular? What we're really asking here is 5/8 more or less than 3/5. So when we're comparing, we're going to use one of these symbols, greater than or less than. So remember, pointing to the right is greater than, pointing to the left is less than. So it's really hard to compare 5/8 and 3/5 because they have different denominators. They have different numbers on the bottom. What we're going to do is we're going to find an equivalent fraction of this that have the same denominator. So what should the denominator of our equivalent fraction be? It's the lowest common multiple of 8 and 5. So the lowest common multiple of 8 and 5 is 40. So if I times this bottom by 5, then this denominator becomes 40. And I times this denominator by 8, then it will become 40. But if you times the bottom by 5, you got to times the top by 5 so that they're equivalent fractions. If I times the bottom by 8, I need to times the top by 8. So 5 times 5 is 25, 8 times 5 is 40. So 5/8 is the same as 25 over 40. Over here, 3 times 8 is 24, 5 times 8 is 40. 3/5 is the same as 24 over 40. Both of them are equal to 0.6. Same thing. So it's much easier to compare the two blue fractions. Clearly, 25 over 40 is greater than 24 over 40. So when you're deciding which of these symbols to use, think of it as a crocodile's mouth. Crocodile eats the bigger number. This one's bigger, so crocodile's mouth eats the bigger number like that. 25 over 40 is greater than 24 over 40, and that means 5/8 is more than 3/5. A higher fraction of students liked soccer than liked rugby league. So that's our answer here. Soccer is more popular because a greater fraction of students like it. All right, let's now look at how we can use equivalent fractions to find a number in between two fractions. So what we're going to do is find the number halfway between an 1/8 and a 1/10. Now, the answer's actually not 1 over 9, as a lot of people think. They just think, oh yeah, 9's between 8 and 10, but that doesn't work. Because of the way fractions work, 1/9 is actually closer to a 1/10 than it is to an 1/8. So how are we going to do this? Well, what we're going to do is we're going to find an equivalent fraction for each of these that has the same denominator. So we've got 1 over 8 and 1 over 10. If I times each fraction by the denominator of the other fraction, then they'll have an equivalent denominator. So I'm going to times top and bottom here by 10. I'm going to times top and bottom here by 8. I'm taking each fraction and timesing top and bottom by the denominator of the other fraction. So if I do that, 1 times 10 is 10. 8 times 10 is 80. Over here, 1 times 8 is 8. 10 times 8 is 80. So I found equivalent fractions. 1/8 is the same as 10 over 80, and a 1/10 is 8 over 80. So the number that's halfway between them, now that they have the same denominator, that's really simple. Halfway between 10 over 80 and 8 over 80 is going to be 9 over 80. And 9 over 80 is a little bit more than 1 over 9. And that's our answer. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.